So thank you for the introduction. My name is Daniel. I'm coming from Ghent University, where I work as a business developer and a postdoctoral researcher at the Department of Industrial Systems Engineering and Product Design. Very long name. And indeed, I'm going to talk about AI-driven projects, data-driven projects, the importance of context, and what we have seen as some barriers in the implementation of these projects, coming from the perspective of working with the SMEs on the implementation of these projects. So I want to start by talking about what everybody's been talking, no? So there is a lot of new words popping up every single day. It's a bit even difficult to catch up. So you have AI, you have LLMs, we have Gen AI, you have agentic AI. You have several names for that. You have ChatGPT 1, 2, 3, 4, 5, and tomorrow there probably will be a sixth. Llama, Meta has a model, Claude, Deep. There's a lot, yeah. And because of that, we have noticed that there is again a renovated and invigorated love for data, yeah, and the belief that if you have tons of data, then you are the king of the world, and then you can solve whatever problem it is, yeah. But the issue there is that there is more to it, and data alone does not necessarily equal value. The data needs to be contextualized, needs to be transformed in order for you to derive from it information. That if you analyze, you can identify patterns, you can identify trends, to transform that information into knowledge that if you thoughtfully apply, you can derive wisdom out of it, yeah? And there are certain key aspects, two key aspects that you need to take into account in order to provide that value to the data, to take it up to that pyramid, to generate some wisdom out of it, yeah? So the first is, you need to consider that context adds value to the data. Without context, your data is just numbers. Yeah, the context provides the step towards information providing from coming from those numbers. And the second aspect is that you need to understand the problem that you're aiming to solve. And I found it nice to hear that in the last presentations that was a focus, and the two of them focus specifically on that, and that means that it is indeed correct. You need to focus on the context that adds the value to the data, and you need to, most importantly, focus on the problem so that you can transform that data into something that's meaningful, into something that's actionable, yeah? Now, I want to then talk about three key aspects that we see are missing, let's say, when it comes to implementing these data-driven projects, mostly from the point of view of SMEs, yeah? So first, again, repeating myself a bit, is framing the problem. Yeah? We have seen some companies coming to us and saying, like, again, we have lots of data and AI is booming. I see that every day. Can we do something about it? And then you start seeing, as in the previous presentation, just all of these headlines on AI is failing. Some people talk about an AI bubble that's about to burst any minute, could be today, could be tomorrow. And the numbers may be different. Some people say 60% of them fail, 80% of them fail. But what's the issue there is that it is understood that there is an underlying problem into taking these problems to a materialized, to return of investment on these initiatives, yeah? So what we would like to see, and when we're happy in engaging with a company mostly, is when the company comes to us with the business case, as we saw in the previous presentation. When they really understand that it is about the problem that they want to solve. We have a performance issue. We want to identify what is the root cause, so we can build a system to solve it. So the idea is then focus then on the pain, on your biggest pain. The pain is the driver for your motivations. The pain is the filter for the data that you're going to need. The pain is the filter for the context that's going to be relevant for the data. The pain is going to be relevant for the specific AI tool that you're going to be using, so that you can build an impactful solution, so you can have a pain reliever and a very good gain, yes? The second aspect is choosing the right tool, yeah? So we talk about LLMs, Gen AIs, several of them, Claude, Mistral, Llama, popping up every day. And they are very good. You see the keynotes of Meta, you see the keynotes of OpenAI, and you're surprised about all the things that they can do. And they are very powerful tools, but they are tools nonetheless. Yeah, and a tool needs to be applied properly. Yes. So first, in order to do so, you have to understand the data that you have. Yeah, you need to understand what are you going to use that tool for. Yeah. So it's not everything about LLMs. You cannot do everything with LLMs. There is a lot of value to be had still and to be found in classical machine learning data. So when you look at your data, you will have structured data, you have unstructured data. And for structured data, I'm talking numbers, quantitative information. There is still a lot of information of value to be found in classical LLMs. For qualitative information, emails, Word, figures, that's where LLMs may thrive, and that's where you can have the value added. So first, understand your data, but more importantly, understand that that the technology must match the problem. It's not the other way around. It's not doing LLMs for the sake of doing LLMs. Yeah, you need to understand why are you using the tool that you are using, and the main driver is the problem that you actually have. And finally, small guides. Finally, look at the full picture. Yeah, there is a lot of information that's literally walking in the shop floor. Human expertise and context complement the data, and they can do it in a very, very big way. So the best approach we have found is about hybrid intelligence. It's about using and leveraging on that human expertise on context to augment the capabilities of your machine learning models, yeah, in order to build a more robust decision-making tool or system, yeah. Now, I want to illustrate this by means of two use cases. These are cases that were basically two research projects that we had in collaboration with companies, in which we see these three things popping around. Yeah. Now, the first one is about quality control, and it's quality control with hybrid intelligence. So we had a project in which an automotive supplier, they came to us. It's an SME, but it's a very well-established SME. And they have very detailed quality procedures. They have a very detailed FMEA, which is a failure mode and effect analysis document, in which an expert writes for every step all the things that can go wrong, the probability that they go wrong, and the causes that they may have. Very valuable information. They have it very well detailed. But the quality was inconsistent between factories, even though they were following the same procedures. They have a company in Japan, a company in Spain, and the quality was inconsistent. So what was going on? So they implemented some machine learning models on IoT data, on specific process steps along their lines, and to try and come out with a reason why things are going wrong and why things are different between plants. And these models could actually determine what was going wrong at each of the steps, and they did that very good. They identified when, for instance, welding was not properly done, but the models work on isolation. The models were tailoring or focusing on a specific process of the line. They were not aware of what happened before or what was happening after. They only focused on their specific step, and they were using IoT data. So they disregard human knowledge, human expertise, and all these exogenous factors. Yeah. So at the end of the day, they were very good at determining what was going on wrong, but not why it was happening. Yeah. So our solution was to create a hybrid intelligence system, and this hybrid intelligence system rely on two key aspects. The first one was on modeling that expert knowledge, that very, very detailed expert knowledge as a Bayesian network that understands cause and effect, and combine this with machine learning models, with those established already machine learning models that use IoT data to replace some of the nodes of the network, to challenge and to refine that expert knowledge, so that if the expert knowledge assumes at the beginning that maybe this specific failure mode happens with a specific probability, the IoT models can challenge that knowledge and tell the system that that probability and that assumption is actually wrong, and it happens with certain probability or happens mostly under these specific conditions. That was one case. The second case is about connecting decision making, yeah? And the specific use case was assembly systems. So in this case, we have a reconfigurable assembly system, which is, in this case, the Infraflex, which is a system from Flanders Make in collaboration with UGent, which you can see over there if you want. And it's a system, it's a very capable system. It's these hexagonal cells. They have add-ons that have multiple capabilities, and you can change those add-ons, send them to another cell, or just store them in a warehouse and change them for a different add-on so that your system can do a multitude of different products and product variances. You can put those cells wherever you want. They have a robot arm with different tooling. You can do a lot with the system, and they are built for agility and they are built for efficiency, yeah, to provide you the capability that you need whenever you need it. The issue with that is that it increases the complexity at the decision-making level by a lot, especially regarding planning and scheduling. Why? Planning is focusing about how you do what you need to do, yeah? So how many cells are you gonna need, how many tools are you gonna need, and so on. But because it's reconfigurable, there is many different ways of doing a certain thing. So it's a combinatorial problem becomes very complex. And then scheduling is always complex. It's about scheduling the tasks in time. So your decision making, because your system becomes more capable, your decision making becomes even more complicated. So how is that done normally? How is that done in industry nowadays? Well, it is done by separating planning and scheduling. You first do planning, and then you do scheduling. And planning, you are normally thinking about cost, because it's about how many machines are you going to need, yeah? And scheduling is about time. And the thing is that time and cost, they are polar opposites. You could do everything with one cell and be slow, or do everything with 100 cells and be fast. So it's always a polar opposite, yeah? Planning is complex and scheduling is complex, and normally you have an algorithm to do that. But then each of those individual algorithms are looking at the problem with different glasses. They're looking at the problem with different eyes. But your objective as a production planner or a plan manager is to have a system that's both cost efficient, yeah? So when you use this approach and you see that the performance is not the performance that you like, then you need to do something about it. So then you need to give some feedback to those independent decision units so they do something else, because if you don't give them feedback, they will keep on popping up the same answer all of the time. And for that, we used some parameters, and those parameters, they basically shape the problem a little bit. So one example, for instance, for planning, you can say to the planner, okay, make a plan to be 100 units with maximum 3 robots, or now do it with maximum 4 robots, or now do it with maximum 10 robots, and you will get your plan, but they will all be different plans, yeah? So those are the kind of parameters and the kind of feedback that you can give. And that an expert could do, or you could devise an algorithm to do it. But the problem is that because those individual steps take so long, and you're talking about an iterative feedback, that process is gonna take a lot of time. And you don't even know how long is it gonna take until you find a solution that you like. So your decision making becomes the bottleneck, yeah? So it's quite funny. You have this super capable system that can do whatever you want, and then the problem is you, yeah? So to solve that, we implemented or developed a machine learning based meta optimization method for integrated planning and scheduling. And the way that worked was that we replaced the planning and scheduling solvers for machine learning models, but the machine learning models were not aiming to predict the optimal plans and the optimal schedules, just to predict what the cost was going to be and what the time was going to be, so that you could optimize for performance to identify the optimal parameters that you will actually give to the solver, so that you don't have to iterate like crazy, yeah? And the good thing about this is that because it's machine learning based, that you can do very rapid scenario analysis, performance-based scenario analysis, and that, as I say, you can just use the optimal parameters that carry on the optimal context of the global problem to the solver so that they can give you the optimal solution. And in some cases, we found reductions of 50% late orders using the same solvers in one single run with the same cost. Now, I talk about we, and I talk about we did this and we did that. So I want to say a little, just take some minutes to tell you who we actually are. So we are I'm from the Department of Industrial Systems Engineering and Product Designs. We have 15 professors, about 50 researchers. We have offices here in Kortrijk and offices in Ghent. We have 3 masters and 1 master after master. We have 3 different research groups. I'm coming from ABISS, which is also a core lab of Flanders Make. There's other colleagues working on design and on interdisciplinary research group with IMEC. And we at ABISS were basically the process auditors and technology matchmakers. Yeah, we are not technology providers. Yeah, our goal is to identify really what the problems of the SMEs are in an objective manner, focusing on the context, focusing on boundary conditions, to ensure that the right solution is applied. Whatever the right solution is, it doesn't have to be a state-of-the-art solution sometimes. Yeah, and most of the times that's not even the answer. We are researchers, but because we work with Flanders Make provides us the venue for innovation. So Flanders Make provides this playground where the end users are, this venue, so that so we can interact with the end users, so that the end users can come to us and tell us what the real issues are. And we can together find a solution. If not, we can also go to Blio. We can have subsidized problems to find your solutions for research or for development. And an example of us doing that, just to put this in perspective, is an European project that's currently running, which is Aid for SME, which is an innovation hub kind of project, with the goal of assist SMEs to develop, combine AI and data solutions to basically for large-scale resource optimization challenges. Yeah. So the way this works is that we, the university, and some of the industrial partners, we provide high and low TRL playgrounds. So, for instance, InfraFlex is one of such TRLs. But we also have some industrial partners providing basically their processing lines as a playground. The end users come to us and they tell us, they bring us the problem that they are actually having. And our task is to generalize and define that problem. And then the solution providers there is an open call and they can come to us and say like, hey, we propose this solution to that specific problem. That's to be tested in the infrastructure. And then we objectively validate those results, quantify the gain, and identify all the boundary conditions. So there was already an open call for this. We have about 300 applications Europe-wide. I think participants will get some funding around 150,000 euro, either SMEs or solution providers. But there will be another call. So if you want to be, if you are interested, just stay tuned. And so to end this talk, I want to repeat a little bit what I say and what some of the other presentations have said, which is really focus on your, oh, there's a typo, on your pain point, not your paint point. Really identify the real problem, select the right technology, quantify the added value, and validate on the real conditions. And don't forget, it's not LLMs for LLM's sake. The technology must match the problem. Yeah. Thank you.